Alright, so let's talk about the CAPM assumptions. So one of the first assumption is capital markets efficient. Alright, it means any changes in the company would be immediately reflected in the share price. Alright, so that is the first assumption. But most of the markets are actually not efficient. So this is one of the first assumptions. And then next, homogeneous investors' expectation are over a given period of time. Alright, it means homogeneous means similar kind of investors, alright, expect the similar kind of investors expectation of a given period of time. And then risk-free rate, risk-free asset return is certain. Alright, so that is another assumption. And then the last one is market portfolio contains only systematic risk. Alright, so these are the assumptions you have. So this is for the RF and this is for the RM. And then we have beta. Alright, so beta measures the stock market's stocks market risk and shows a stock's volatility relative to the market. Okay, so it's important to understand what is beta. Alright, it measures a single company's market risk, alright, relative to the overall market. Alright, it measures, if let's say for AirAsia's beta is 1, that means it compares AirAsia's market risk compared to the overall market. Okay, so that is beta. Indicates how risky a stock is if the stock held in a well diversified portfolio. Again, we have this assumption. Alright, why we have this assumption? Because if a well diversified portfolio, you don't have or you have very minimum diversifiable risk. Alright, so that is why we assume well diversified. Therefore, we are interested or only focus on systematic risk, not the unsystematic risk. Alright, so let's look at the comments on beta. If beta equals to 1, that means the security is just as risky as the average stock. Alright, compared to the overall market, your particular companies have the same risk. That is when you get beta equals to 1.0. If beta is more than 1, if let's say your company's beta, if let's say company like Top Glove at 1.5, it means your company is riskier than the overall market. Alright, anything more than 1, that means your particular company is riskier than the market. If less than 1 means your company is less risky than the overall market. Alright, so the most stocks have betas in the range of 0.5 to 1.5. Alright, so let's look at the market risk premium. Alright, so the additional return over the risk-free rate to compensate the investors assuming on average amount of risk. Alright, so that it means what is the additional return? Right, you should be compensated for the additional risk you're taking. Alright, so its size depends on the perceived risk of the stock market and investors' degree of risk aversion. Alright, so it depends on the stock market, overall stock market, as well as the how the investors, what kind of risk aversion, risk appetite of the investors. Alright, so it varies from year to year, but most estimates suggest that it ranges from 4 to 8%. Alright, so in the most cases would be 4 to 8%. So let me show you an example. Okay, so let's take an example where your market return is 10%. Right, which means average return from the market of Bursa Malaysia is 10%. Right, maybe you have take 100 companies in Bursa Malaysia, on average giving 10%. And then risk-free rate, RF. Alright, risk-free rate means what? you are investing in a corporate where the risk is almost zero. There's no risk investing in a particular stock. Usually it is from government bonds. Alright, only government bonds, you can consider those as risk-free rate. Right? So let's say 4%. Your market return is 10%, your risk-free rate is 4%. Therefore, your risk premium is 6%. So what is the 6%? Instead of I'm investing in government bond, which is risk-free, there's no risk. Alright, instead of investing in government bond where there's no risk, I'm investing in a company. Alright, in a company, or on average, company is getting 10% return. So what is the extra compensation provided for the additional investment risk I'm taking? So that is called risk premium. Alright, instead of no risk, I'm taking risk. So how much I'm getting extra? That is called risk premium. Okay. Alright, so this is security market line. Alright, whatever, if you use the capital asset pricing model, and using the capital asset pricing model, you can actually basically plot this diagram. Alright, so this is risk-free rate. Alright, so this is the market return. When you have both these points, you can basically connect the lines. Alright, so if you look at beta equals to 0, you got your risk-free rate. Alright, beta equals 0 means what? There's no risk. Beta equals to 1 means your company is as risky as the overall market. That is why we are having market return. Alright, so beta equals to 1 means is your market return. So once you have both of this, you can plot the line, and those companies that has fall above the security market line, you call them as undervalued, and those who falls below the security market line, those are overvalued stocks. Okay, so let's say your company is getting 1.5, your beta is 1.5, and your return is above this. That means you are undervalued, and here is overvalued. Alright, so let's look at the expected return. Alright, so the expected return, also known as the mean. Right? So expected return are based on the probabilities of possible outcomes. In this context, expected means average if the process is repeated many times. And the expected return does not even have to be possible return. Right? So it's just an expectation. So how do you calculate expected return? Probability times the return. Alright, so let's do an example. Alright, suppose you are required to predict two companies' expected return. One is stock C, another one is T. Alright, so how do you calculate your expected return? The formula is probability times the return. Alright, probability times the return, probability times the return, add up all, you get your expected return. But look over here, your probabilities. You have three different states. One, the state is boom. Alright, second is normal, third one is recession. The market is doing well, is 30% of the chances. The normal is 50%. So what is the recession? Should be 0.2. Alright, so class, even though if there's one missing, you should know it is 1 minus 0.3, 0.5, therefore it's 0.2. Because when you add up all your probability, it should be 100%. Or if you have a decimal point, that means equals to 1. So let's calculate your probability for C. 0.3 times 15, 0.5 times 10, 0.2 times 2. Add up all this together, you get 9.99%. Therefore, for company C, on average, with all the different probabilities, you're adding them together. For company C, you expect to get 9.99% return. Alright, so if you repeat the same thing with 0.3 times company C's return, you add up all together, you're getting 17.7% return. So based on the return, which one is better, C or T? Of course, company T, because it is higher than company C. So if based on expected return, you would have choose company T, right? Okay, so just now we calculated return. Now let's calculate risk. So we're going to calculate risk using variance and also standard deviation. Alright, so this is a symbol sigma square. Given an asset's expected return, the variance can be calculated by following, which is return minus expected return square times with probability. Remember, return minus expected return, alright, which you calculated previously, the whole thing square times with the probability. Alright, so that is how you calculate your expected return. Calculate variance. Once you calculate variance, the next step is standard deviation is quite easy, which is square root your variance. Once you get your variance, square root your variance, you get your standard deviation. Alright, just now sigma square is your variance, right? So square root, you get sigma. Okay, so standard deviation measures total or standalone risk. Alright, so standard deviation is what we usually use in order to make a conclusion decision, because it measures the total risk, total standalone risk. Therefore, the larger the standard deviation, lower the probability that actual return will be closer to expected return. Means what? Higher the standard deviation, your real return would be different, alright, compared to your expected returns. So the larger the standard deviation associated with wider probability of distribution of returns. Okay, so let's see an example here. Alright, so consider the previous example and we calculate variance and standard deviation. So how do you calculate variance? Return, alright, your company C's return when the state is boom would be 15 minus your expected return that you calculated 9.99, the whole thing square times with probability, right? So return at that particular state minus expected return square times probability. So this is when the state is boom, when the state is normal, and when the state is recession. So add up all together, you get 20.29 as your variance, and square root your variance, you get standard deviation. Alright, square root your variance, you get standard deviation. For stock T would be 74.41 and your standard deviation is 8.63. Alright, so based on this, which company will you choose based on risk? Company C company T. Remember, higher the standard deviation, higher the risk. So based on risk, stock T has a higher risk. Right? Stock C has a lower risk. So if you're making decision by risk, then of course you choose C. Right? So what are the comments on standard deviation as a measure of risk? Alright, standard deviation measures the total of standalone risk. Alright, so it's basically repetition from the earlier slide, which is on the measure of standard deviation. Alright, so it's basically just a repetition. Alright, the next measure is coefficient of variation. Alright, once you calculate standard deviation, divide with the expected return. So coefficient variation calculates risk per unit of return. So for example, for every dollar of return, how much of risk I am taking. Alright, so that is the usage of coefficient of variation. So the statistical measurement of a relative dispersion of an asset return is useful for comparing the risk asset with differing average expected return. Alright. Alright, if your projects have one is saying high risk and the other one is high return, so which one you going to choose? At that kind of situation, you use coefficient variation. It's an easier measure because you're calculating based on per unit of return. Alright, so you can make a decision better using coefficient of variation if you have differing average or expected return. So let's do another example. Alright, so class, I think you can take a piece of paper. Alright, we have I've shown you example on expected return, variance, standard deviation of coefficient variation. So class, why don't you pause the video now and calculate the expected return, variance, standard deviation as coefficient of variation. So class, hope you have attempted the example, and you should be getting expected return equals to 8.05, your variance is 26.75, your standard deviation is 5.17, and your coefficient of variation is 0.64. Right, so make sure you get these answers. Alright. Alright, so class, with that I will conclude today's chapter on risk and rates of return.